For millions of years, the changes in Earth's climate have been driven by forces of nature. But for the last century and a half, Earth's average temperature has been rising faster than any time in the past 10,000 years. The consensus in science is that much of that change has been driven by us.
We're on a track to 700 parts per million of carbon dioxide on the planet. We haven't seen that for 50 million years.
The signs are everywhere. Droughts in the American Southwest and Africa's Sahel, rising seas in Louisiana and Bangladesh, tropical diseases spreading north, and extremes of weather from Florida to France.
The climate is not what it used to be. It's not your grandfather's climate anymore.
You know, there are people who still say global warming needn't concern us. If it's happening at all, it's a natural trend, not much we can do about it. But there's now hard evidence which shows that the warming is not only real, it's accelerating. It's altering the climate's most basic elements, like rainfall and evaporation, days of sunshine and nighttime temperatures. Those changes are damaging the environment and agricultural production, threatening wild species with extinction, and putting at risk our lifestyles, our health, and some of our favorite cities by the sea. In the next hour, we'll follow the signs and see who, if anyone, is responsible. We'll meet scientists who are investigating new climate evidence, and we'll see what we can do to help. It all starts with the warming. But up here in the eastern Arctic, reports of heat waves and droughts seem far away. Inuit guide Ben Kovic is more concerned with the melting.
Fossil Mountains? Yeah, Fossil Mountains up there.
The disappearance of sea ice and snowpack on a scale that's hard to grasp. Over the last 100 years, the world has seen a 1 degree Fahrenheit rise in its average temperature. But here and in Alaska, the average has climbed 4 to 7 degrees Fahrenheit in just 50 years.
The ice is forming a lot later than usual over the past few years, and it is breaking up a lot earlier. So that means the less ice there is, the less hunting that can be done by our people, and that means less country food. It means there's been a great shift in terms of the seasons and the changing of the environment in the Arctic here.
Earth's polar regions are signaling us that something unusual is happening. In the Antarctic, in January 2002, the Larsen B ice shelf broke up into small pieces. An area about the size of Rhode Island melted in less than a month. There is also melting in the world's mid-latitudes. These are NASA time-lapse pictures of Africa's Mount Kilimanjaro. Its snow cap is retreating year by year. And the famous Swiss Alps may one day have no more glaciers.
We are now at the actual melting front of the glacier. And this glacier retreats actually at the rate of about 30 to 40 meters a year. This is about twice as much as the average retreating rate of the last 150 years.
But global warming isn't just melting the ice. It is triggering large-scale climate changes of every kind. The seasons have become unsettled. Atmospheric highs and lows are migrating to new regions, basically changing the way our daily weather works. But what are the causes, and why is all this happening now?
We know that climate is not controlled by just purely one thing, and in the case of the human control, it has resulted in changes to the chemistry of the atmosphere in the form of greenhouse gases and toxic metals, which are unparalleled in rate and also magnitude for the last many millions of years. The instabilities that those could create in the climate system could be very dramatic.
Every day, solar radiation streams down on Earth's surface. As the land and the oceans warm, they radiate some of their heat back out into the atmosphere. Some of that heat is then trapped by naturally occurring gases like water vapor, methane, and carbon dioxide. It's called the greenhouse effect. And for millions of years, it's kept Earth's climate livable. But why is the greenhouse starting to get too warm? The answer is that the sun which warms the greenhouse also fuels a process that cycles carbon from the atmosphere and stores it underground. Author Tom Hartman calls it current and ancient sunlight.
Through the majority of human history, we lived on current sunlight. Sunlight falls on the ground, stimulates plant growth. Plants trap that energy, the heat energy from the sunlight, through photosynthesis to form carbohydrates. And we would eat that, or we would eat animals that ate that. They ate current sunlight. And then, more or less largely about 1,000 years ago, in some parts of the world, we started using sunlight that had been trapped in the earth hundreds of thousands to millions of years ago, primarily coal. And that was the beginning of the use of ancient sunlight, sunlight that had been trapped by plants a long time ago and buried in the earth. Now we're liberating that carbon into the air as we burn this ancient sunlight, as we burn these fossils. And we're moving in the direction of returning the atmosphere toward the way it was before the dinosaurs.
The sources of carbon vary by region, but most researchers cite transportation for about 33%. Electric power generation in the U.S. produces about another third. While heating our homes, manufacturing, making cement, agriculture, and clearing forests account for the rest. The result is that the concentrations of CO2, which remain in the atmosphere for 100 years, have increased from 280 parts per million during the Industrial Revolution to 370 today, and it may climb to 500 within our lifetimes.
Now, carbon dioxide is very important because it's a greenhouse gas. Carbon dioxide is also physiologically important. It drives photosynthesis. It controls your blood chemistry. And you are saying we are going to change this by a factor of 2 and we don't expect any consequences? I don't need to understand the consequences in detail to be very concerned that there will be some.
Unfortunately, modern lifestyle demands energy. And without question, the United States is the biggest economy, the biggest energy consumer, and the biggest greenhouse gas emitter in the world. But that's today. By 2050, most economists predict China's economy will be larger than that of the US. More than 1 billion people are likely to want the same size appliances and automobiles you have. In Beijing, the Luos and the Ling family are buying the first cars their families have ever owned.
We are looking for cars more like stylish. You know, I seldom drive. Most of the time she drives, so we're looking for...
Car ownership here has grown 500% since 1990.
Doesn't need to be really big, but it has to be cute.
By 2030, China will import as much oil as the US. But oil is only part of the problem. Coal-fired factories and power plants are the world's most often cited polluters. Like the US, China has huge coal reserves. And if their economy grows as projected, at 10% a year, their contribution to global warming could be enormous. But why should the developing world cut back if we won't? And why should we cut back if they won't?
I don't think so. Any country have the right to ask others to do something, especially, you know, as you mentioned, the developed country, most of them emit more right now, and still emit more.
Another factor in climate change is global population increase. Though births in Europe and Japan may actually decline, the rest of the world's babies could push the population to 9.3 billion people by mid-century. 3 billion more than today. And a growing middle class will likely contribute solid middle-class expectations.
So far, we have put out about 300 billion tons of carbon. At current rate, it will take us 50 years to do that again. If we keep growing like we did over the last century, by the end of the century, we will talk about 1,000, 2,000, 3,000 billion tons of carbon. So these scales have changed. In the past, so far what we have done is we tweaked the system. Now we are going to overwhelm the system.
Too many people and too much carbon pollution are already threatening human life. And the first symptoms are both widespread and deadly. Hotter summers have started to overwhelm the world's great cities, and prolonged heat waves have triggered tragedy. In France, in the summer of 2003, they ran out of space in the Paris morgues, and bodies had to be stored in refrigerated tents.
Think of the way people live in urban areas like Paris. A lot of concrete, very little green space. No one lives in individual homes. Everyone is crammed together.
Lawrence Kalkstein is one of the world's leading authorities on urban heat threats. He says it's the sudden spikes in temperature, not the gradual warming, that take the most deadly toll on these close quarters.
If the climate variability increases, and if in fact, let's take New York, most of the summer days are still in the 80s, but now you have a larger percentage of days in the 90s and over 100, in my opinion, there is no doubt that heat-related mortality is going to increase. In every way imaginable, a northeastern U.S. type urban setting is probably the worst you could possibly imagine for heat-related mortality, and I might even add even worse than in most third world cities.
Even without global warming, big cities run 3 to 5 degrees hotter than their surroundings.
I can see it in the air at certain times of the day when I'm riding. This haze of smoke on certain avenues where there's idling cars, traffic jams.
But add in global warming, and unhealthy air days could increase by 60%, according to a recent study.
I realize this mask doesn't stop everything, but it keeps the soot and the gutter dust out of my face.
Bike messenger Paul Lamarca is not the only one fed up with the air that he breathes. In a landmark 2004 case, New York City and 8 states said enough and sued America's 5 largest electric utilities for immediate reductions in carbon dioxide. Opponents hammered the legal merits of the case, but New York State Attorney Peter Lehner says no one, including the defendants, denied that global warming isn't happening.
So here we have a situation where it would be terrific if the federal government were acting, and we believe that the science and the economics and the technology all demands a aggressive and strong federal reaction in response to global warming. But we don't control the federal government, so we take action where we can.
In Detroit, the fight for healthy air is being waged on a more local scale.
People of color and low-income people, usually because the majority of people who are low-income are people of color, are more affected by climate change and environmental impacts than other communities.
Nia Robinson is hoping to help these students understand the challenge, because in inner city neighborhoods, bad air and heat waves have killed and will kill again.
When you start talking about the health effects of climate change, the toxic emitting facilities are usually located in the neighborhoods where these people live. So the problem is not only that their air quality is bad, it's that they're living right next door to power plants or incinerators or car factories or freeways. And then we're walking through here wondering, oh God, it smells so bad, and these people have to live with this every day. When you grow up there and you live there and every day this is what you see, you start to believe that this belongs here with you. And so when your kids are sick, you don't necessarily equate that with this factory down the street. It's just, oh, my kids are sick, and so are the kids down the street.
I feel like, especially when it comes to depending on our generation to come along and really help and support the environmental movement, it's so hard because, you know, we have been coined the bling bling generation, and all we care about are the Escalades and the clothes and the cars and getting more and more and more. And like you said, it's hard to do the give and the take, and I don't think that as a whole we really want to give and take and say, well, I'll give up that house or that car for the environment. They don't care about that.
The reason that most humans aren't environmentalists is because they don't feel like they're a part of the environment, and they are. They're an intricate part of the environment. And so I think that what's important is to get people to understand that you're a part of this cycle. You don't control it, you're a part of it. And what you do to harm it harms you.
While inner city dwellers are more at risk than most, climate change is affecting people's health all over the world.
In the last 2.5 decades, we have seen the emergence of 30 diseases new to medicine.
Rising temperatures are expanding the range for infectious diseases like Ebola and Vibrio cholera. Alongside those diseases, excess CO2 is fertilizing the microorganisms which trigger allergies like hay fever and, more deadly, asthma.
One of the unexpected impacts of just carbon dioxide fertilization of plants, with experiments of ragweed, which we see growing right here, with doubling of ambient CO2, we found that the growth went up 9 or 10%, while the pollen production went up 61%.
The impact of CO2 on plants and us is startling. But it's the climate's changes in precipitation patterns and the droughts which laid the groundwork for recent outbreaks of hantavirus and West Nile virus. In the summer of 2003, a human health disaster began to unfold in Greeley, Colorado. The first clues were dead birds, discovered in increasing numbers. Then horses started to die. Then people.
It was on TV every night, and to protect yourself and wear bug spray. But I hadn't even seen mosquitoes or been aware of them, so I didn't take any precautions.
We had a very moist spring, and then right after that, we had a very hot beginning of the summer. Set up perfect conditions for the mosquito breeding cycle to be shortened, set up the perfect storm for us.
With fully half the total American cases of West Nile virus, Greeley became a national story.
We certainly weren't expecting the number of cases, and the spectrum of disease has been quite broad, from individuals who have a little muscle ache, some joint pains, and a low-grade fever, to individuals who've had life-threatening encephalitis.
For me, it turned into meningitis. So, you know, I had a brain infection, and I was disabled. It was difficult for me to walk. It's been very difficult for me to think, even now, which has been 2 months later.
Sharon's infection was high profile and deadly, but how many cases were not even reported?
For every one patient that we see who comes to our attention, there are at least 150 people who do not come to our attention. So we would extrapolate from that and say that here in the state of Colorado, we've had probably, on the order of 200,000 individuals who have been infected with the West Nile virus.
While medical science is working on vaccines to cure West Nile, climate science is trying to forecast where the next outbreaks may occur. But understanding where our climate is heading is very difficult because it's such a complex system. 20 years ago, scientists didn't have sophisticated satellites or probes, nor the supercomputers to analyze mountains of data to make accurate projections. But now we're starting to decode some of the great mysteries of our climate. Its circulation patterns and pressure zones, the interplay between the atmosphere and the oceans. We're discovering how these systems work and why they're changing. Violent storms have been part of life long before human record-keeping began. But there's convincing new evidence that warming sea temperatures are intensifying these deadly events. For the last 2 decades, scientists have been probing the most powerful of these climate systems. It's called the El Niño Southern Oscillation, and it sets the pattern for much of the world's climate. Normally, the prevailing trade winds blow westward across the Pacific, pushing a current of warming equatorial water before them. As a result, the sea level is about 20 inches higher, and the sea temperature is about 14 degrees Fahrenheit warmer in the western Pacific than in the east. During El Niño periods, which used to occur every 5 to 7 years, the trade winds weaken, allowing the warm water to drift back towards South America. This reverse movement pulls major atmospheric systems along with it, changing weather patterns all around the world. In some places, it increases the rain. In others, it brings severe drought. But El Niños appear to be coming more frequently, And climate scientists are investigating whether global warming is stirring them up in unpredictable ways.
Well, the El Niño is a heat transfer. It's Mother Nature moving heat, transporting heat from one place to the other. So if there's more heat in the global system, in other words, global warming, then it's likely that there'll be more tweaking of the dial, Mother Nature trying to balance the heat around the planet. So we may see stronger events, we may see more frequent storm events. We don't know that yet, but certainly the whole fabric of this Earth and this system is interconnected.
Mother Nature did more than tweak the dial in 1983. This is Colan, near the equator in Peru. Villagers here rely on fishing as their primary source of food. But the El Niño of '83 changed all that.
Aguacero. 5 meses que no había sol. Y noche se caía aguacero. La mar fue un maremoto que hubo. Maretazo, quebró todas las casas y no podíamos salir a la pesca.
Well, in 1983, the beach of Colan was almost completely destroyed. Actually, what you see now is a little bit of reconstruction. What happened is that the ocean level in 1983 went up 55 centimeters for 2 months. No, this was not a tide, it was the sea level 55 centimeters higher. Puree has 50 millimeters of rainfall a year in the average. You know, it's just 5 centimeters of rain in the average, including Niños. In 1983, it rained 2,500 millimeters, 50 times more. In 3 months, it rained as much as 25 years altogether.
The village of Colan was extremely vulnerable to this major kind of climate event. But it's not alone. Here along the Atlantic seaboard, rising sea levels threaten entire communities. The sea rise is being driven by melting coastal glaciers in the high polar regions and by the slow expansion of the warming oceans. Recent studies warn that all of New York's subways and tunnels could flood, and Miami's beachfront hotels could be hit by 15-foot-high storm surges. But in late August of 2005, the warning flags along the Gulf Coast were flying. New Orleans sat waiting well below sea level, protected by a levee.
Right now it's about 17 feet above lake level, and in Hurricane George, it got within about, I think, 2 to 3 feet of the top of the levee. So of course now we're all thinking about building the levees a little bit higher.
It didn't work. The aftermath of Hurricanes Katrina and Rita has become America's most documented disaster. But the devastation of the Gulf Coast has been underway for decades. Before Katrina destroyed his lab, Shay Penland spoke with us from a Louisiana barrier island.
Just this last fall, we had 2 storms. Right where we're sitting right here now, the shoreline eroded 290 feet in a week. Since 1932, we've lost over 1,000 square miles of land.
In fact, the Mississippi Delta was losing the equivalent of 1 whole football field of dry land every 15 minutes. But just as frightening, southern Louisiana has the nation's only deep-water offshore oil port. This was Port Fourchon before Katrina, and this is now.
This one little place on Earth plays a strategic role in somewhere between 16 to 18% of this entire nation's hydrocarbon supply. And with coastal land loss on both sides impacting the highway, the vulnerability of our energy supply is increasing daily. We also have about 20,000 miles of pipelines in coastal Louisiana that were designed for being under the marsh and not for being in the Gulf of Mexico. So as the sea level rises and land subsides and the sea takes the land, those pipelines become exposed to a much harsher environment than they were designed for. And you just can't replace 20,000 miles of pipelines overnight. So it's a tremendous environmental situation that we're going to have to deal with in this next 20 to 50 years, starting now.
Folgett's fears were justified. Soon after Katrina and Rita, the infrastructure struggled at far below capacity, and U.S. gasoline prices soared to unprecedented heights. The climate patterns that may have contributed to recent Gulf Coast disasters have left far too little moisture in the American Southwest. The drought that started here in 1996 had, by 2004, killed off most of the piñon trees across 3 million acres.
Old-growth forests and woodlands here in the Southwest take at least 200 years to grow and develop. Yet a severe drought like this can cause those forests to die back in just a couple years. The bark beetle outbreaks can kill the trees in just a few weeks, and the severe fire events can consume a forest in just a few hours.
Scientists suspect the current drought may be part of a natural cycle, triggered by those fluctuating sea temperatures in the Pacific. Or could the changing climate be warning us that these trees may disappear from here forever?
Well, the key thing about climate change, and it relates especially to warming, diminishing the amount of snowpack that occurs in the mountains and on the plains. And if so, there's no soil moisture when you go into the summer months, it has a vicious feedback and tends to create conditions that are much more favorable for drought, and drought that is long-lasting and quite devastating. And those are the sorts of things we're likely to see as we move into the future with global warming.
In Delta, Colorado, that long-lasting drought has already arrived, and it's changing an entire way of life.
Last year, it was horrible. We had no rain. All the ponds, springs, most of them dried up. We were selling double the amount of cattle last year that we normally would in the summertime. This year it's affected us the same way because these guys are trying to hold off. They don't want to buy feed and all the other.
Mark and Robbie LaValle run 400 head of cattle on a ranch that's been in Mark's family for over 100 years. She's an agricultural extension agent and attributes the region's troubles more to changing climate patterns than to the heat.
This is the 4th year of non-typical moisture. The total precip for the year still looks okay, but it's that timing of when the moisture came that is really altered what we see. And last year was severe, low snowpack, no rain whatsoever as far as spring rain, no monsoon rain in July or August. And so we saw a lot of things happen from the plant standpoint and just no water for irrigation. The other thing we've seen is there's been this whole infestation of other things. We've had cutworms and grasshoppers and all these other factors that have come into play. So it's been kind of this triple whammy.
Biggest thing that got us last year was water. We had feed. We had to sell cows because we didn't have enough stock water to get us through, and we couldn't afford to haul. And we knew hay was going to be high, and we didn't raise a pound of hay on this outfit. We kept thinking it's going to rain and do something, but it never did.
A lot of these guys I grew up with, the LaValles and Hotchkiss, most of that I spent a lot of my life up there. They're still young enough that they can get back in this thing.
Times the money now. 15 head, 900, bid a quarter. 900, not a bid now, quarter, not a bid now, quarter. Watchman.
The ones that bothered me is the 55 to 70-year-olds that when they went out this year and last year on the drought, they probably will never come back.
25 here, 820, sold $600, buyer number 6.
It's not just livestock in Colorado that's under stress. The world's entire food supply may be vulnerable to climate change.
We expect climate change to aggravate current weather extremes.
Martin Perry headed the impacts report of the Intergovernmental Panel on Climate Change, which projected long-term changes in precipitation.
It will tend to make already dry areas, the arid and semi-arid tropics, drier because the amount of evaporation due to the higher temperatures will reduce water availability. For example, in this part of southeast England where I'm standing now, a 1 degree increase in temperature will generally reduce water availability by about 10%. We would need 10% more rainfall in an average year to make up for that 1 degree warming.
That same 1 degree of average warming would slash 10% off the world's rice yields, which provide a staggering 30% of Earth's food supply, raising grave concerns about the convergence of climate change and population increase.
So we're talking about 2.5 to
to 3 billion more mouths to feed on a world with limited amounts of good arable land and water. And so to achieve food security 40 to 50 years out, the amount of food we're going to have to produce is going to be at least 60% greater than the amount of food we're producing today.
So we're dealing with serious questions. The world's foremost food crop is at risk. Coastlines are eroding. Our western heartland is drying up. And human health is under threat. The more science we do, the more we understand how future climates might work. But some of those findings may bring unpleasant surprises. Could we be nearing some invisible tipping point where sudden changes in the climate stop civilization in its tracks? Or could Mother Nature turn on us? A case in point. It's widely assumed that forests store away much of our excess CO2 emissions, which help us breathe better. But investigators in the Rocky Mountains have unsettling evidence that an excess of fixed nitrogen coming in from the atmosphere may be upsetting all that.
I'd rather not. We're studying nitrogen because it is part of the carbon dioxide story. You, me, plants, every other living thing on Earth is made up of carbon plus other elements, other nutrients. And nitrogen is one of those, and in fact, it's an essential nutrient. Now, it's an interesting...
Basically, like you or I, anybody else, the soil and everything that lives underneath there, plants and microbes, breathes. So as they breathe, just like us again, they're releasing carbon dioxide.
What the team is investigating is whether elevated levels of nitrogen in this soil are stimulating microbes into a feeding frenzy down in the old stored carbon.
About 8. So by adding nitrogen, the hypothesis is that we've given them more access to that food, more respiration, more carbon dioxide coming out of the soils.
If nitrogen is triggering the release of more stored carbon, where's that nitrogen coming from? Well, apparently it's coming from us. Every time we burn fossil fuels, we produce nitrogen. Every time we fertilize fields or manure piles up, we're spreading nitrogen around.
In Colorado, we have this very nice situation where we can actually pinpoint where our pollutants come from because there isn't very much out of here. Every night when cold air drains down from the bottom of the mountains, because you know cold air sinks, it sinks down to an area in the middle of the South Platte River Basin, about the town of Greeley, and it pools there. So all the air pollution that comes with it from Denver and from the agricultural fields pool down there, and every morning when the air rises as it warms up, it comes back up the mountains. So it's coming from Greeley, from the lower part of the mountains, against the prevailing winds because it's moving with hot air rising, moves up here to the tops of the mountains where you get summertime clouds. These summertime clouds condense, take all those pollutants, dump them down on the ground. And that's where we're getting the nitrogen.
If this nitrogen cycle is repeated elsewhere, many of the world's forests won't be absorbing much CO2. They may even start releasing it. Out at the far end of the climate spectrum is a worst-case scenario in which an increasingly warm atmosphere would trigger abrupt climate changes. Unpredictable and stunning shifts in both temperature and precipitation that can bring on almost instant drought or deep freeze, devastating perhaps just one region or the entire planet, and lasting for decades, even centuries. It has happened before.
We've only known for about 15 years that the Earth had this capability of undergoing large, this means global, abrupt, this means a couple decades, changes, so that the whole system has reorganized many times in the last 100,000 years.
Brooker believes the trigger lies in the North Atlantic. Much of northern Europe enjoys ice-free conditions all year, thanks to an ocean conveyor belt that transports warm water from the tropical Pacific and up the Atlantic. When the warm water contacts cold Arctic air, it cools, becomes saltier and more dense, and sinks to the ocean floor, returning south on the same path. But if fresh water from melting glaciers and icebergs is added, the current's density is gradually reduced and it can't sink to the bottom. The whole system stops operating, and rapid climate shifts may quickly follow, some lasting up to 1,500 years.
these events start and stop in less than 10 years. Arguably, some of them start and stop in less than 2 years, and they are immense events. The ones that occurred more than 12, 14,000 years ago were events that were so dramatic that there were changes in places like Greenland on the order of 10, 20, perhaps 25 degrees centigrade shifts in temperature that occur in less than 10, maybe less than 2 years. None of these rapid climate change events is going to suddenly result in a massive ice sheet dropping from the sky and covering North America. But we don't have to experience anything anywhere near that big to be very, very vulnerable to climate change.
So we're doing a dangerous thing. We could luck out, or we could have the worst case scenario. So prudence would say, for God's sake, stop putting CO2 in the air as rapidly as possible.
It was hoped that the Kyoto Climate Protocol in 1997 would start doing just that, by establishing targets for developed nations that would reduce their carbon emissions to 1990 levels. After that, developing nations like China and India would adopt similar limits. But with a U.S. refusal to sign, the effect of the Kyoto Agreement will be limited. What's of more concern to many of the world's scientists and environmentalists is that Kyoto was only a first and very modest step.
The likelihood is we would need probably 10 or even 20 times Kyoto level reductions to reduce CO2 forcing in the atmosphere to a point where climate change is no longer a problem.
I don't think the planning is adequate. There are some very long time constants built into this thing. When you put emissions of carbon dioxide into the atmosphere, it takes a long time for that to have its full effect, because the oceans heat up very slowly. Sea level rises very slowly. And so these things have ramifications for decades, centuries into the future. And so we need to start planning for it as soon as possible, and I don't think we're doing that.
And remember, it took 100 million years of the coevolution of climate and life to give us the distribution and the kinds of species we have. And to have one generation or 2 generations of one species, us, so clawing over each other to get richer faster that we didn't stop to think about what kind of damage we could be doing to tens of % of the rest of the creatures, I think people in the future might look back at our generation and say, what was wrong with their value system?
This is not primarily an economic issue in my mind. This is primarily a moral issue. And to ignore it means putting billions of people at risk around the world who are much more vulnerable to the immediate impacts of climate change. It means dishonoring the work of all these generations of men and women who've worked so hard to bring us the civilization that we enjoy today. And it really means consigning our children to a future of disintegration.
So what can we do? If we agree global climate change is taking place, there are 2 approaches that will work just as well for us as they do for companies and governments. First, on an individual level, we can start adapting to the new realities of a new climate. Prepare ourselves. Second, and just as important, we can slow down the rate of global warming by reducing our impact on the atmosphere. Basically, cleaning up the way we live. That's where a lot of Americans are putting their efforts. The kids at Harper's Choice Middle School belong to a generation likely to be most affected by global warming. Happily, they seem to understand that and enjoy getting involved with environmental programs like the Energy Alliance.
Before I started Energy Alliance, I would never turn the lights off, always leave them on. Now I'm getting a lot better, and I'm putting the computer to sleep, which I learned saves a lot.
2 computers are on. That's also not good.
Here in Maryland, these kids are auditing their school to check for energy wastage.
So she gets a friendly reminder. Okay.
Teachers who leave lights and computers on are given a ticket and told to be more careful. The kids love that.
I got a friendly reminder. Says I left my lights on, and they caught me with my computer on.
Nice weekend, guys. The program allowed us to develop in kids a real passion, an interest and a passion for what they do, particularly in this case in the environment. I mean, these are the kids who, as they get older, will get actively involved in the environment, in our planet.
All over the world, it seems, this is a message which kids understand and care about. Here in Beijing, at the Showpiece Eco School, good citizens of tomorrow get ready to take this message to their homes and families. Change your life. Help slow down the global warming. The impact of carbon pollution worries the Beijing authorities as they prepare to host the Olympic Games. China recently set new emission standards that are stricter than most of those in the US, though actually enforcing them countrywide may prove more difficult. In Beijing, however, taxis are given many incentives to convert to natural gas. At least one cabbie has found that it's cheaper and healthier, and you don't have to speak Mandarin to understand his relief.
因为一旦摇下来以后，呛眼睛和鼻子很难受。就说从这个烧了气以后，北京市这个天气变化很好，太好了。
For China, this is a first step on the road to cleaner air. In the US, however, there's an uphill battle to change the car culture, mainly to introduce clean technologies that could steer our automotive obsessions in the right direction. This is the annual Future Truck Competition between 15 university engineering schools. The challenge is, whose new technology will outperform its gasoline counterpart and burn fuel cheaper, cleaner, and more efficiently?
This truck behind us is a split parallel hybrid electric parallel diesel electric hybrid.
3-transmission parallel hybrid.
Hydrogen fuel cell powered. Ethanol electric hybrid.
Diesel electric hybrid.
Hybrid diesel electric vehicle with a
modified 4-liter with a small internal combustion engine and a powerful electric motor.
Top prize this day went to Wisconsin's biodiesel hybrid, which delivered an impressive 45% more miles per gallon, while cutting carbon emissions in half. The fact is, there are a number of electric drive hybrid cars, trucks, and buses already on the market, and not necessarily where you'd expect. In 2001, the Sheriff's Department of Martin County, Florida, became the first law enforcement agency in the country to add hybrid vehicles to its fleet.
Well, I'm always looking for new things. I like to be on the edge in technology, and I'm always willing to make a change if I have confidence that it's the right thing to do and will have a benefit. So it wasn't a big leap for me. I was kind of eager to try it out.
Sheriff Crowder now has a number of different hybrids in his fleet of 22, and that number is growing each year. The first payoff has been an impressive 60% reduction in fuel costs. The cars are used for a variety of non-pursuit applications, in most cases replacing aging, low-mileage police cruisers. And acceptance is growing.
Some of our friends made fun of us because this isn't a normal police car. When they gave me mine, I had mixed emotions, but I enjoy that car now because part of my job is to drive through neighborhoods or look for either suspects, or sometimes we have to do runaways. If you're in a regular police car that's unmarked, people pick up on it really quick. They don't even give my car a second glance.
Beyond hybrid technology may lie the much heralded hydrogen economy. But even its advocates agree it's at least a decade or more away. In the meantime, some very bright people are simply doing ordinary things a different way.
A 5, 6, 7, 8.
This is a rehearsal for Climate Change the Musical in Keene, New Hampshire.
Disease vectors, health sectors.
People here are excited about meeting the challenge of keeping Keene green.
Manufactured denial, non-linear feedback events.
The city council decided to do what they could by reducing carbon emissions in every activity controlled by the city. They're using low-polluting biodiesel fuel in all their trucks and heavy equipment.
Scientific uncertainty, climatic variation.
And while this recycling plant looks fairly standard, it's actually powered by methane, which comes from the old landfill next door.
This is one of 17 interconnected wells that basically supply a pipeline that directs down to that blue building down there, which is simply a diesel generator that's been modified to run on methane gas. And it goes into our electrical transformers, and 3-phase power is produced and single-phase power is produced. We came up with a business case, essentially, that showed that producing our own power on site was not only feasible, it was highly desirable and very favorable from an economic standpoint. The power company sends us a bill each month. It's about $7, and it's the cost of mailing us a bill.
So then, how about you? How about what you do? You drive that big car just to go to the store that's just 1 mile away. And don't get us started about how hard-hearted you are when it comes.
Small wonder the people of Keene are embracing their new green identity.
Okay, oh, there's something else over here I gotta show you. This is really cool.
There is a revolution going on in energy-efficient home construction all over the world, and it's being spearheaded by radical young architects like Chris Holmes. Just a few years out of architecture school, he's reinventing the concept of affordable green living.
In a few years, we're gonna have a big eco-building empire across the country, I have no doubt.
This is a working-class neighborhood in Montreal, where Holmes has developed a radical concept for affordable multifamily housing. Each 2-story unit is cheap by big city standards, less than $150,000 US. They're cheap to rent or buy, and even cheaper to run. A homeowner will only pay about $50 US a year for heating, cooling, and hot water.
Okay, so what we did here is we brought the windows out of the building in order to maximize the amount of sun coming into the building from the sun as it travels across the sky. And that light energy is coming in and stored in the concrete floors, and that helps to provide over 60% of the heat for this building. Up on the ceiling, this whole ceiling acts like a giant radiator, either circulating heat or cool, depending on the season. That's provided by our geothermal heat pump in the basement. And finally, we have a lot of energy recovery techniques that we use. We recover energy from all the waste water. We recover energy from the waste air that goes out. We also have incredible windows in this building. This is really cool.
As Chris's projects are demonstrating, there are untapped reserves of geothermal energy everywhere underneath us, not to mention independent, emission-free energy from sources and technologies that already exist. In fact, wind farms near Altamont, California have enough capacity to supply electricity to 500,000 households. And a federal study estimates that wind power potential in the Dakotas, Kansas, and Texas alone could supply all of U.S. electrical demand. But even that doesn't match the potential of the sun. Each day, more solar energy hits Earth than its 6.4 billion people could consume in 27 years. But you don't have to live in the Sun Belt. Contractor Lyle Rawlings is bringing solar into the energy mainstream in New Jersey by helping union electricians learn the ins and outs of the technology.
Solar energy is actually the most intensive job creator of any form of energy. It creates 4 times more jobs per kilowatt hour generated than fossil fuels such as coal. It's manufacturing jobs, it's installation jobs, it's technicians that do servicing, a lot of high-quality technical jobs that are being created right here in New Jersey.
At the top of the customer satisfaction list is the moment they start selling electricity back to the power company.
And as soon as we flip the switch, we'll see that meter slow down and stop and then start to spin the other way, and people love to see that.
It's too good to be true. The sun comes up and you produce power. Why are we not doing this? There are no emissions, and there's no cost of the power. Why are we not doing more?
Tom Layden's company produces large-scale photovoltaic arrays. His Fortune 500 customers see solar as a long-term investment, and Layden hopes more politicians will start to do the same.
It really comes down to policy. All we have to do is grow the industry like it's growing right now, and we could produce 100% of our power in the next 35 years. This system alone will save about 5,000 tons of CO2 production over the next 30 years. In terms of barrels of oil, that's 28,000 barrels of oil, the equivalent energy that this system will produce.
For many of those 30 years, over half of U.S. electricity will still come from coal-fired power plants. And the older plants will remain among the country's worst contributors to air pollution and atmospheric warming. There are new technologies that would let countries like the U.S. and China use their huge domestic coal reserves and reduce some of the pollutants. Coal gasification is a partial solution that produces 50% more power and cuts most of the sulfur and nitrogen, which reduces both smog and acid rain. But its CO2 emissions are still a problem. On the horizon is a truly zero-emission coal technology. But in the meantime, our atmosphere keeps on warming. Research to reduce CO2 emissions is happening in some surprising areas. Agriculture and land clearance have been part of the problem, contributing up to 20% of all the world's greenhouse gases. Now, they may become part of the solution, if scientists have their way. In this experimental field, they've reduced the fertilization, computers control the irrigation, and there's minimum tilling of the soil. What they're looking for is an answer to a fairly simple question.
To what extent can some of our major cropping systems here in the central USA Corn Belt contribute to alleviating some of the greenhouse gas emissions that are occurring? So here at the University of Nebraska, we have a production scale field experiment. These are not small plots. And we're using progressive management practices that we think are going to be those practices that farmers will be using in 10 to 20 years. We're asking the question, under those conditions, how much carbon can they store from the atmosphere? Because plants fix carbon dioxide in their tissues, and if the net balance of that fixation is greater than the emissions of carbon dioxide from the cropping system, then we have a net carbon sequestration. That means that we're storing carbon in the ground, in soil organic matter. And that then would contribute to a reduction in the greenhouse gases in the atmosphere.
If these plants can store some of the excess CO2, perhaps artificial plants could do even more. In the New York City suburbs, 16-year-old Claire Lackner and her father Klaus are working on a great experiment. Their goal is nothing less than to undo the damage of global warming.
Well, the basic idea was just to use different chemicals to collect carbon dioxide. So like we used a fish pump just to pump the air through the solution. And now I'm looking at this tower that he's designed that is basically the same idea, just a lot bigger.
Klaus's plan is a landscape of synthetic trees, inhaling CO2 out of the air just like real ones. The leaves on his trees will be giant veins saturated with chemicals like calcium hydroxide. When the wind blows, that will react with CO2 in the air to form harmless calcium carbonate, the stuff of seashells. The chemistry seems reasonable, but the towers will have to be very large.
If you want to put that in perspective, if you look at the skyline, it would be comparable to these buildings you see over there. On the order, you might think of 50 by 60 meters as the area on which we collect, and this whole thing stands on a pedestal, maybe another 50 meters tall, so the wind collecting area is on the order of 160 by 200 feet.
Each device would collect the continuous excess CO2 emitted by 4,000 people or 15,000 cars. To deal with all of today's CO2, we'd need 250,000 towers, which could be anywhere, because CO2 is everywhere. Plans like the Lackners may be optimistic, but funding for a prototype is in place. So could these radical solutions and best efforts actually stop climate change? Well, it's pretty clear that with a world growing so quickly, in so many ways, it can only be slowed, not stopped. Climate change is deceptive because its signs occur almost imperceptibly. So the question becomes, what happens next? Can we wait for new technologies to save the planet? Or for governments and big business to take the first steps? The fact is, many solutions to slowing down climate change are already here, or very close. We just have to start using them. Because every day our glaciers shrink, the oceans rise, and storms become more deadly. Western ranchlands become a little drier. Insects and disease creep a little further north. And the air we breathe gets a bit more toxic. If just a 1-degree rise in the global average temperature is responsible for what we've seen, consider that scientists have projected an additional warming of up to 2 degrees by 2050. In our lifetimes, we're all likely to feel its effects. Because as you've seen, there's much more to global warming than just the heat.
environmentalists is because they don't feel like they're a part of the environment, and they are. But they're an intricate part of the environment.
Just this last fall, we had 2 storms. The shoreline eroded 290 feet in a week. Since 1932, we've lost over 1,000 square miles.
The program allowed us to develop in kids an interest and a passion for what they do, particularly in this case in the environment. These are the kids who, as they get older, will get actively involved in the environment, in our planet.
Cities by the sea. In the next hour, we'll follow the signs and see who, if anyone, is responsible. We'll meet scientists who are investigating new climate evidence, and we'll see what we can do to help. It all starts with the warming. But up here in the eastern Arctic, reports of heat waves and droughts seem far away. Inuit guide Ben Kovic is more concerned with the melting.
Fossil Mountains? Yeah, Fossil Mountains up there.
The disappearance of sea ice and snowpack on a scale that's hard to grasp. Over the last 100 years, the world has seen a 1 degree Fahrenheit rise in its average temperature. But here and in Alaska, the average has climbed 4 to 7 degrees Fahrenheit in just 50 years.
The ice is forming a lot later than usual over the past few years, and it is breaking up a lot earlier. So that means the less ice there is, the less hunting that can be done by our people, and that means less country food. It means there's been a great shift in terms of the seasons and the changing of the environment in the Arctic here.
Earth's polar regions are signaling us that something unusual is happening. In the Antarctic, in January 2002,
could be very dramatic.
Every day, solar radiation streams down on Earth's surface. As the land and the oceans warm, they radiate some of their heat back out into the atmosphere. Some of that heat is then trapped by naturally occurring gases like water vapor, methane, and carbon dioxide. It's called the greenhouse effect. And for millions of years, it's kept Earth's climate livable. But why is the greenhouse starting to get too warm? The answer is that the sun, which warms the greenhouse, also fuels a process that cycles carbon from the atmosphere and stores it underground. Author Tom Hartman calls it current and ancient sunlight.
Through the majority of human history, we lived on current sunlight. Sunlight falls on the ground, stimulates plant growth. Plants trap that energy, the heat energy from the sunlight, through photosynthesis to form carbohydrates. And we would eat that, or we would eat animals that ate that. They eat current sunlight. And then, more or less largely about 1,000 years ago, in some parts of the world, we started using sunlight that had been trapped in the earth hundreds of thousands to millions of years ago, primarily coal. And that was the beginning of the use of ancient sunlight, sunlight that had been trapped by plants a long time ago and buried in the earth. Now we're liberating that carbon into the air as we burn this ancient sunlight, as we burn these fossils. And we're moving in the direction of returning the atmosphere toward the way it was before the dinosaurs.
The sources of carbon vary by region, but most researchers cite transportation for about 33%. Electric power generation in the U.S. produces about another third. While heating our homes, manufacturing, making cement, agriculture, and clearing forests account for the rest. The result is that the concentrations of CO2, which remain in the atmosphere for 100 years, have increased from 280 parts per million during the Industrial Revolution to 370 today, and it may climb to 500 within our lifetimes.
Now, carbon dioxide is very important because it's a greenhouse gas. Carbon dioxide is also physiologically important. It drives photosynthesis. It controls your blood chemistry. And you are saying we are going to change this by a factor of 2 and we don't expect any consequences? I don't need to understand the consequences in detail to be very concerned that there will be some.
Unfortunately, modern lifestyle demands energy. And without question, the United States is the biggest economy, the biggest energy consumer, and the biggest greenhouse gas emitter in the world. but that's today. By 2050, most economists predict China's economy will be larger than that of the US. More than 1 billion people are likely to want the same size appliances and automobiles. For millions of years, the changes in Earth's climate have been driven by forces of nature. But for the last century and a half, Earth's average temperature has been rising faster than any time in the past 10,000 years. The consensus in science is that much of that change has been driven by us.
We're on a track to 700 parts per million of carbon dioxide on the planet. We haven't seen that for 50 million years.
The signs are everywhere. Droughts in the American Southwest and Africa's Sahel, rising seas in Louisiana and Bangladesh, tropical diseases spreading north, and extremes of weather from Florida to France.
The climate is not what it used to be. It's not your grandfather's climate anymore.
You know, there are people who still say global warming needn't concern us. If it's happening at all, it's a natural trend, not much we can do about it. But there's now hard evidence which shows that the warming is not only real, it's accelerating. It's altering the climate's most basic elements, like rainfall and evaporation, days of sunshine and nighttime temperatures. Those changes are damaging the environment and agricultural production, threatening wild species with extinction, and putting at risk our lifestyles, our health, and some of our favorite. Larsen B ice shelf broke up into small pieces. An area about the size of Rhode Island melted in less than a month. There is also melting in the world's mid-latitudes. These are NASA time-lapse pictures of Africa's Mount Kilimanjaro. Its snow cap is retreating year by year. And the famous Swiss Alps may one day have no more glaciers.
We are now at the actual melting front of the glacier, and this glacier retreats actually at the rate of about 30 to 40 meters a year. This is about twice as much as the average retreating rate of the last 150 years.
But global warming isn't just melting the ice. It is triggering large-scale climate changes of every kind. The seasons have become unsettled. Atmospheric highs and lows are migrating to new regions, basically changing the way our daily weather works. But what are the causes, and why is all this happening now?
We know that climate is not controlled by just purely one thing, and in the case of the human control, it has resulted in changes to the chemistry of the atmosphere in the form of greenhouse gases and toxic metals, which are unparalleled in rate and also magnitude for the last many millions of years. The instabilities that those could create in the climate system